Hello everyone, this is the second topic in the series, which is about the transformations of functions and other relations. It is fundamental to understanding graphs of all sorts, and therefore we should take a deep dive into this topic before we introduce any other generic functions, such as trigonometric functions or exponential functions. We will discuss this topic in two parts. First, we will consider the transformations of points, and of course their inverses. That's really easy. However, it builds a very concrete basis for us to consider transformations of functions and relations. A good understanding of transformations of points will help you very much in understanding the transformations of functions. Now, what's a transformation? A transformation of the plane is really just a one-to-one mapping, which assigns each point, P naught, in a particular set, to a new point, which is the transform point. We consider three types of transformations. The first one is obviously translations. We can be given an initial point P naught, and if we want to move it right by h units and up by k units, then we simply add h to its x-coordinate and k to its y-coordinate. This is quite easily visible on the graph. For example, a point P naught is here. Then getting it to the right by h units and up by k units moves it right to here. Now, what's important is that this is the algebraic expression of a translation. Now, next up, we introduce horizontal and vertical dilation. If we are given a point P naught and we would like to dilate it by a factor of a in the x direction, then the result is simply a times x naught in the x-coordinate, and y-coordinate is interchanged. Similarly, if we want to dilate in the y direction and by a factor b in the y-axis, then we simply multiply the y-coordinate by b. As a remark, however, the following wording is equivalent to the one we have, which is that dilation by a factor of a in the x direction is equivalent to, say, dilation by a factor of a from y-axis. Let's see this in the graph. So horizontal dilation by a factor of a basically magnifies the horizontal component by a, and the same of a dilation from the y-axis by a factor of a is actually identical. It's just a different wording, but it means the same thing, and you need to know that. Now, vertical dilation. Suppose I want to dilate my point y naught by a factor of b in the y direction, then we just multiply the y-coordinate by b, and that's the result. Of course, we could apply both a vertical and horizontal dilation at the same time, and it's simply leading to a pathwise treatment of the coordinate. As a special case of dilations, if we make the y-coordinate negative, then it's a reflection in the x-axis. Similarly, if we make the x-coordinates negative, then it's a reflection in the y-axis. Now notice that that's simply putting the dilation factor as -1. Graphically, it's simply like so. If we had an initial point above the x-axis, then flipping the vertical coordinate reflected by the x-axis, and we will obtain x naught minus y naught. Similarly, reflecting in the y-axis will cause a change in the x-coordinates.